Okay, guys, we'll continue with the next question in the algorithm subject. So, match the algorithm with their time complexity. Match the algorithms with their time complexity. So, here at one side, the algorithms are mentioned and their time complexity. The Tower of Hanoi with n disks. Tower of Hanoi with n disks. Binary search given n stored numbers. Heap sort given n numbers at the worst case. Addition of two n by n matrices. So the correct answer for this is, so this Tower of Hanoi, is O of 2 raised to n. O of 2 raised to n. Tower of Hanoi with n disks. That is big O of 2 raised to n. Then binary search with given n stored numbers, so that is big O of log n, big O of log n. Then heap sort with the n numbers are stored in the worst case, so that is O of n log n, O of n log n. And for n by n matrices, that is big O of n square, big O of n square. Okay, so the Tower of Hanoi with n disk is O of log n, O of log n. Then binary search given in a n stored numbers, that is, so here the Tower of Hanoi is big O of 2n square, right? So this is P big O of 2 raised to n. Then binary search is for this one O of log n. Binary search for a n stored number is O of log n. And for addition of two matrices is the S is O of n square. Then heap sort is heap sort. Okay, so that is the R, the heap sort given number at the worst case, is O of n log n, right? O of n log n. So that is uh, R is 2. Okay, so Tower of Hanoi is O of 2 raised to n. Then binary search for a given stored number is O of log n, O of log n. And heap sort for a given number at the worst time, that is O of n log n. 2 by 2 n matrix is O of n square. In this problem, we have to find the average case of different algorithms. The Tower of Hanoi with n disk is big O of 2 raised to n time. It is a mathematical game or the puzzle. Okay, big O of 2 raised to n. It is the Tower of Hanoi is a mathematical game or puzzle. It consists of 3 rods and a number of disks of different size, which can slide onto the any rod. The puzzle starts with the disk in a neat stack in ascending order of size on the one rod, and the smallest at the top, thus making a conical shape. The objective of this puzzle is to move the entire stack onto the another rod, obeying the following simple rules. Only one disk can be moved at a time. Only one disk can be moved at a time, and each move consists of taking the upper disk from one stack and placing it on the top of the another stack. No disk may be placed on the top of the smaller disk. No disk may be placed on the top of the smaller disk. So with 3 disks, the puzzle can be solved in 7 moves. 3 disks that can be solved in 7 moves. The minimal number of moves that required to solve the Tower of Hanoi puzzle is 2 raised to n minus 1, where n is the number of disks. Okay, so that is O of 2 raised to n. The time complexity is required for Tower of Hanoi, that mathematical puzzle game type, and binary search for n sorted array is O of log n to O of log n to the base 2. For heap sort for n numbers is O of n log n, and for a matrix is n square. Okay. The next question is, consider the recursion function t of n, that is 2t of square root of n plus 1, where n is greater than 2, and 2 where n is greater than 0 and less than or equal to 2. Where this function t of n in terms of the notation is big O log n. Okay. So here the 2t square root of n plus 1. So this square root of n is n raised to 1 by 2. N raised to 1 by 2 plus 1, where n is assumed 2 raised to k, where we will get 2t into 2 raised to k by 2. Assume that t of 2 raised to k is equal to s of k. So here we will get 2s in 2s of k by 2 plus 1. So apply the master theorem, a is equal to 2, b is equal to 2. Okay, so here we will get O of log n. O of log n is the answer for this particular recursion function, O of log n. Consider the following C function. The function int n, int ij, for loop. So here there is a first for loop, second for loop, print. The time complexity of the function in terms of the notation is big O notation. So here the time complexity for this is, here there are two for loops are there, where I is equal to 1, I less than equal to n, I plus plus, where j is equal to 1, j less than or equal to n, and j plus equal to I, j is equal to j plus I value. Okay. So for this the time complexity is big O of n log n. So here we can solve these iterative programs with time complexity help with the help of rollback method. The function int n, where int I comma j, for I is equal to 1, I less than or equal to n, I plus plus. So it is it is an independent loop. Independent loop, the first loop. So it takes O of n time. The first loop O of n time, independent loop. And next it is a dependent loop. This j here, j plus equal to I. So this dependent loop, it always incrementing with the help of I. Okay, it is, so j is equal to j plus I. It is incrementing with the I value. So it will take approximately O of log n times. O of log n times. O of log n times. And it takes O of one time to print. So the overall complexity of the program is O of n log n times. O of n log n times. Okay, here one independent and dependent loops are there, two loops. Next question. A message is made up of entirely of characters. A message is made up of entirely of the characters from the set X. From set X contain the elements P, Q, R, S, T. The table of the probabilities for each of the probabilities of each of the characters is given below. So the uh, message is made up of the characters from the set. So these are the characters P, Q, R, S, T, and their probability is, the probability for P is 0.22, 0.34 for Q, 0.17 for R, 0.19 for S, and 0.08 for the T. So these are the some probability. If a message of 100 characters, if a message of 100 characters over the X is encoded using the Huffman encoding, if a message of 100 characters, okay, if a message of 100 characters over the this set X is encoded using the Huffman coding, if a message of 100 characters, how many there is a message of 100 characters, there is a message of the 100 characters, or the X is encoded using the Huffman coding, then the expected length of the encoded message and expected length of encoded message in the bits is. Okay, so here if a message of 100 characters we are making over the X is encoded using the Huffman coding technique we are using here, then what is the expected length of encoded message, the length they are asking. So the answer is 225. So let us see how it is. The characters, the probability they are given PQRST. So general procedure to solve the Huffman coding problem is arranged. Step 1 is arrange into either the descending or the ascending order according to that profits. Ascending or descending according to their profits, and apply the optimal merge pattern procedure. Optimal merge pattern procedure. So here make the left subtree value either 0 or 1 for right subtree, vice versa. So here the weights are arranged in a descending order: point through 34, 0.22, 0.19, 0.12. Okay, it is not 0.12, it is a 0.17, 0.17, okay, and 0.08. So here 0.34, 0.22, 0.19, and these two 0.17 and 0.08. So here these two values, the left subtree values either 0 or 1. So here they formed a tree with by taking these the elements, these values 0.17 and 0.07. So here so these addition 0.217 and 0.08 is how much? So 0.34, 0.22, 0.19, right, 0.17, 0.08. The profits are arranged in decreasing order. So now addition of these 0.25, right? So 0.34, then the 0.25, the two element is replaced by 1, and 0.22 and 0.19, right? Next so here uh, it is a combination of point, this one, this element. Okay, now now the next thing is 0.41, 0.41, so that is 0.32 and 0.19. So using Huffman coding, so here it's a 0.22 this one, this is actually 0.22, so 0.22 and 0.19, so that is 0.41, then 0.34, then 0.25. Okay, so next this one 0.41, 0.59. 59 means here this will come first, right? 0.59 and 0.41. So this will come here 0.59, 0.59 and 0.41. Okay, so this is the T. So 1.5.9, 0.41. This is means 3, 4 and 2, 5, 2, 2 and 1 1. So this is 1.17, and so here, so 2 into 0.34 plus 2 into 0.22 plus 2 into 0.19 plus 3 into 0.08. Here this 342219, and here this this is 17. Okay, the code here, the code for this, it is 1 2 3. Here for Q it's a 0 0, then Q, and for P it is 1 0 1 0. Okay, 1 0 1 1. So that is point 2 into 0.34 plus 2, 0.22 into 0.22 plus 2. So here we will get, for the 100 characters we will get 225, we will get 225. You just go for the Huffman coding concept. Then the worst case running times of insertion sort, merge sort, and quick sort. The worst case running time, for insertion sort, merge sort, and quick sort. So here is the answer. The worst case for the insertion is big O of n square, merge sort is big O of n log n, quick sort is O of n square. Okay, so the worst case for the insertion sort. Okay, it's a big O of n square. Worst for insertion sort. Merge sort is O of n log n, and quick sort is big O of n square. Big O of n square is the time complexity. The worst case running time for insertion sort, merge sort, and quick sort. Then what is the best case? The best case for the insertion sort is big O of n, merge sort is big O of n log n, and quick sort is big O of n log n. And average case for the insertion sort is O of big O of n square, merge sort is big O of n log n, and quick sort is big O of n log n. So the worst case for the insertion sort is big O of n square, merge sort is big O of n log n, and worst case, so this is the insertion sort. Here this is merge sort, and quick sort is big O of n square. Big O of n square. Big O of n square is the quick sort. The worst case for the quick sort algorithm. Next question. Let G be a complete undirected graph with 4 vertices having the 6 edges with the weights being 1 2 3 4 5 6. The maximum possible weight that a minimum weight spanning tree of the G can have. There are 4 vertices, 6 edges they are given, with the weights are they given. The maximum possible weights that a minimum weight spanning tree of G can have. So here, so there are 4 vertices A, B, C, D, 6 edges, and according to graph theory, if we use the Prim's or Kruskal algorithm, the graphs will look like this, and there weights 1 2 3 4 5 6. Okay, so now consider the vertex A to make a minimum spanning tree with maximum weights. The as the weights 1 2 3 4 5 6, so AB, AD and AC. AB, that is AB means like AB is 4, AB, AD, that is 5, and AC, that is 6. So these are the maximum weights, right, out of 1 2 3 4 5 6. Now next consider the vertex BA. The vertex BA and a minimum spanning tree with maximum weights. Okay, maximum weights. The vertex B, here if we consider the BA, the vertex B with the BA equal to 4, the weight, and the minimum spanning tree with maximum weights. Next is BD. Next is BD and BC. If we consider this, means if we consider the vertex B with BA equal to 4, the next the minimum spanning tree with maximum weight is BD and BC. BD and BC. So that takes a 2 and 3 respectively, and at the last edge CD, that is 1. So 1 plus 1 plus 2 plus 1 plus 2 plus 4. 1 plus 2 plus 4 in our graph will be the minimum. 1 plus 2 plus 4 in our graph will be the minimum spanning tree with maximum weights. So the answer is 7. Okay, minimum spanning tree with maximum weights means here we consider consider the vertex. Okay, maximum weight means here the AB, AD and AC, these are maximum weights. Considering the vertex B with BA4, the minimum spanning tree with maximum weights. The next to B is BD. BD is 2 and BC is 3. Okay, BD and BC is 2 3 respectively. So okay, so here for minimum spanning tree, so here we consider this 4 value and 2 and 1. 4 plus 2 plus 1, so that is 1 plus 2 plus 4, 7. Consider one more example. Let V the graph vertex with edges undirected simple graph in which each edge has distinct weights. Each edge is having the distinct weight. E is a particular edge of graph G. So which of the following statements about the minimum spanning tree of the the graph G is true? Okay, so there is a graph undirected simple graph in which each edge has the distinct weight and E is the particular edge of the G. So which of the following statements about the minimum spanning tree of the graphs are true? So let E is the highest edge of some cycle. E is the highest edge. These are the statements they are given. E is the latest edge of some cycle in graph G. Then every minimum spanning tree of the G includes E. E is the latest edge of some cycle in the graph G. Then every minimum spanning tree of the G includes E. So E is the heaviest edge of some cycle in the graph. Then every minimum spanning tree of the graph G that excludes the E. So that excludes the E edge. E is the heaviest edge. Okay. So here the correct answer is true. This second statement is true. The statement 1 is false because the minimum spanning tree of the graph may or may not include the latest latest edge may or may not include the latest edge. So take a rectangular graph that is labeled with PQRS. So connect PQ, QR, RS, okay, SP and PR. When we are performing this cycle, the latest edge of the cycle, so the minimum spanning tree, so ABCD with the cost is 11. Okay, so the latest is, the first statement is false and the second statement is true. Suppose there is a minimum spanning tree with the which contains the heaviest edge E contains edge E. If we add one more edge to the spanning tree, we will create a cycle. Suppose if we add edge E to the spanning tree with generated cycle C, we can reduce the cost of the minimum spanning tree if we choose an edge other than E from the C for removal, so which implies E must not be in a minimum spanning tree, and we get a contradiction. So the second statement, if E is the heaviest edge of some cycle in the graph, then the every minimum spanning tree of the graph that excludes the E. Second statement is true. So the next is, assume that the algorithm considered here sort the input sequences in the ascending order. The input here the algorithm that considered that sort the input sequence in the ascending order, and if the input is already in the ascending order, which of the following is true? Okay, if it is input is already in the ascending order, so which of the following is true? The quick sort runs in quick sort that runs in O of n square time. Bubble sort, so which of the following is true if the input is already ascending order? So that is first and four are true. Quick sort that runs O of n square time, so that is a worst case time. The worst case time of quick sort, that is O of n square, and insertion time is O of n, means here if it is already in the ascending order, so insertion sort that runs in the O of n time. So these are the two wrong. Bubble sort runs in O of n square, merge sort runs in the, these are the two false. So the correct is the quick sort that runs in the O of n square time, and insertion sort O of n time. If the input sequence is already in the sorted, the time complexity of the quick sort is O of n square, and bubble sort will be O of n. So merge sort will take O of n log n. Merge sort will take the O of n log n, and insertion sort will take the O of n. Merge sort will take O of n log n, and insertion sort will take the O of n. The recurrence relation for a quick sort, if the elements are already sorted, then T of n equal to T of n minus 1 plus O of n. With the help of the substitution method, it will take O of n square. So the recurrence relation for merge sort is, if the element is already sorted, then it is O of n log n. Okay. Then the next question, the Floyd-Warshall algorithm for all the pair shortest path computation is based upon. So Floyd-Warshall is a dynamic programming paradigm. It is a dynamic programming paradigm. Okay. Floyd-Warshall algorithm for all pairs of shortest path. So it is a dynamic programming paradigm. All pair shortest path algorithm, it is using the dynamic programming technique, and it takes the worst case time complexity of O of V3, O of V cube. The worst case space complexity is O of V square. The Floyd-Warshall algorithm is an algorithm for finding the shortest path in the weighted graph. Floyd-Warshall is to finding the shortest path in a weighted graph with positive and negative edge weights. Floyd-Warshall algorithm is an algorithm for finding the shortest path in a weighted graph with positive and negative edge weights. A single execution of the algorithm will find the length. Single execution of the algorithm will find the length of the shortest path between the all pairs of vertices. All the pairs of vertices. Although it does not return the details of the path themselves, but it is possible to reconstruct the paths with a simple modification in the algorithm. So, uh, flared flared Warshall algorithm is a shortest path algorithm is using the dynamic programming technique. The next question: let A1, A2, A3 and A4 are the four matrices of the dimension 10 is to 5, 5 is to 20, 20 is to 10 and 10 is to 5. The dimensions they are given. Minimum number of scalar multiplication is required. Minimum number of the scalar multiplication is required to find the product. The product A1, A2, A3, A4 using the matrix multiplication method is. So here in this case the 1500 is the correct answer. So let us check how it is. The minimum number of this scalar multiplication required is 1500. The optimal parenthesis sequence is it is possible A1 of A2 A3 of A4 out of many possibilities. So in this way, if we perform this, what is this? A1 of A2 and A3, A2 and A3, okay. Then A4, A2, A3, A4, okay. So in this way, we can A2 and A3, A4. So here they are given the dimensions. So here we will get 1500. This is the best possible. There are other possibilities are there, A1, A2 of A3 of A4, okay, but the best possibility is A2 and A3 of A4 of A1. So the A1, the dimensionality is 10 into 5, okay, 10 into 5. So here we have to do in this way, A2 and A3, this is 5 into 2, 20 into 10. A2 and A3 means we have to do this in the matrix multiplication, so we will get the 1500. The given diagram that shows that flowchart for a recursive function, assume that all the statements except for the recursive calls have big O of one time complexity. If the worst case time complexity of this function is big O of n raised to a, then the least possible values of that alpha is least possible values. It's accurate up to 2 decimal position of alpha. So here it's a 2.3219280. So how it comes? So this flowchart they are given. Start a of n by 2 with the condition. So here this type of problem we have to consider the worst case time complexity, and it means all the possibilities according to the flowchart. So total there are 5 worst cases possibilities of function calls. So this is one function call, second, third function call, 4 and 5. So five worst case possibilities of the function calls. So the remaining function calls, that return statement will execute only the constant amount of time. So total 5 function calls are there. So the recursion will be 5a of n by 2 plus big O of n. Apply the Master's theorem. A is equal to 5, b is equal to 2, k is equal to 0, p is equal to 0. So here we'll get this alpha value. Okay, so n raised to log 5 to the base 2. So n square, and we'll get 2 the alpha value will get as, so 2.239820. Which one of the following is the recursion equation for the worst case time complexity of the quicksort algorithm for sorting the n numbers? So n is greater than or equal to 2 in the recursive equation given the options given below, where c is the constant. So here t of n equal to t of n minus 1 plus t of 1 plus c into n. When the pivot element is the smallest or largest element of partitioning the block size n, the result is one empty subblock. So the one element, that pivot element in the occurrence in the correct place, and subblock is size n minus 1. So here the recurrence relation is t of n minus 1 plus t of 1 plus n. T of n minus 1 plus t of 1 plus cn. For a recursion equation, the worst case time complexity for the quicksort algorithm, n minus 1 plus t of 1 plus cn. Next, consider one more question where algorithms are given. So here the Prim's algorithm for minimum spanning tree. So Prim's algorithm, so as you know, Prim's algorithm is a greedy method. Okay, Prim's algorithm is a greedy method, and Floyd-Warshall algorithm for all the shortest paths. So it is a dynamic programming. So that is 3. Then merge sort. It's a like divide and conquer. Merge sort is a divide and conquer. Hamiltonian circuit. It's a backtracking. Hamiltonian circuit is a backtracking. Hamiltonian circuit is a backtracking. So the Prim's algorithm is for minimum spanning tree is a greedy method. Floyd-Warshall algorithm for all the shortest path is a dynamic algorithm. Then merge sort is a divide and conquer. Hamiltonian circuit is a backtracking algorithm. Backtracking Hamiltonian circuit. So the correct option is third. Prim's algorithm is always select the minimum distance between the two of its sets, which is nothing but a greedy method. Distance between two of its sets, which is nothing but the greedy method. Floyd-Warshall always changes its distance at each iteration, which is nothing but the dynamic programming. So merge sort, in merge sort, first we always divide and merge to perform the sorting, hence divide and conquer method merge sort. Then Hamiltonian circuit is used to reach the entire vertex once. So if some vertex is repeating in its path, then it will be backtrack. Some vertex is repeating, so its path will be backtrack. So next question. An algorithm that performs log n to the log n raised to 1 by 2 find operations, log n raised to 1 by 2 find operations, n insert operation, find operation, n insert operation, then log n raised to 1 by 2 delete operations, log n raised to 1 by 2 decrease key operations on a set of data items with keys drawn from linearly ordered set. So for delete operation, a pointer is provided to record that must delete it, the record that must delete it. So for decrease key operation, a pointer is provided to record that its key is decreased. So which one of the following data structure is most suited for the which data structure is most suited for the algorithm to use? So if the goal is to achieve the best asymptotic complexity considering the all operations, so that is unsorted array. Unsorted array means if the goal is to achieve the best total asymptotic complexity considering the all operation. So that is unsorted array. Unsorted array. Here for unsorted array. So the find operation big O of n log n raised to 1 by 2. For n insert O of n. For delete big O of n of log n raised to 1 by 2. Then decrease key big O of log n raised to 1 by 2. So in this case, for an algorithm that performs this log n raised to 1 by 2 find operation, n insert operation, log n raised to 1 by 2 delete operation, and log n raised to 1 by 2 decrease key operation on the sets of the data items. So with the key drawn from the linearly ordered sets. For delete operation, a pointer is provided to record must be deleted. For decrease key operation, a pointer is provided on the record that has keys decreased. So which one of the following data structure is most suited for the algorithm to use if the goal is to achieve the best asymptotic complexity considering all the operation? So the correct answer is unsorted array. Unsorted array where the time complexity it takes. Okay. The next the graph is shown below. It is having the 8 edges with the distinct integer edge weight. 8 edges are there. So 3, 3, 6, 7, 8. 8 edges with the distinct integer edge weight. Minimum spanning tree of the weight is 36 and contains the edges AC is 9, BC is 2, B is 15, and EF is 4, and DF is 6. So DF, EF, BE 15 and BC. Okay, then AC. Okay, so this is the minimum spanning tree. So 11, 26, 30, 36 the weight, right? So the edge weight of any only those edges which are minimum spanning tree are given in the figure. The minimum possible sum of the weights of all the 8 edges of the graph is the minimum possible sum of the weights of all the 8 edges of this graph is 69. So here how it comes 69 is the question is that the minimum possible sum of the weights of all the edges. So here the AB, AC, BA, AC, then CB, then BE, then ED, okay, ED, then ED, then DC, okay, 16 and 6 plus 4 plus 6. So total for all the possible, okay. So 10, 9, 19, 21, 21, 26, 36, 42, 52, 59, 59, 69. And they asked the question about the minimum possible sum of the weights of all 8 edges of this graph. All the 8 edges means it will how much? 69. 69 is the total sum. So next there is some algorithms are given and design paradigms. So here this Floyd-Warshall algorithm to compute all the shortest path. So that is dynamic programming. So this is very important. I think 3 questions where we have seen such type of question. Floyd-Warshall is dynamic programming. So here these two are eliminated. Then for Dijkstra shortest path. So that is a greedy algorithm, quick sort and all greedy algorithm. Dijkstra shortest path is a greedy design. Dijkstra shortest path is a greedy design. And for binary search sorted array, so that is a binary search on the sorted array is divide and conquer. Binary search on a sorted array is a divide and conquer method. Divide and conquer. Binary search on a sorted array is a divide and conquer method. Then fourth one, backtracking search on a graph. So that is depth first search. Backtracking search on a graph is depth first search. So the correct option is 3. Okay, so the Dijkstra algorithm is greedy design. Floyd Warshall algorithm to compute all the pairs of shortest path is dynamic programming. Binary search on a sorted array. Binary search is divide and conquer algorithm. Then backtracking search on a graph. So that is depth first search. Depth first search. Okay, that is fourth one. Okay. So digital shortest the path using to find a single source shortest path. Find the single source shortest path. It is purely based on the greedy technique because it always select the shortest path among all. Shortest path among the all, and all the pairs of shortest path algorithm is using the dynamic programming technique. All the shortest path algorithm that Floyd Warshall that takes the dynamic programming technique, and it takes the worst case time complexities of O of v3, O of v cube, and for space complexity O of v square. The Floyd Warshall algorithm is an algorithm for finding the shortest path in a weighted graph with positive and negative edge weight. It considers the positive and negative edge weights but with number of negative cycles. A single execution of the algorithm that finds the length, the summed weight of the shortest path between all the pairs of vertices, although it does not return the details of the path themselves. So it is possible to reconstruct the paths with a simple modification of the algorithm. Next is binary search on a sorted array. So search a sorted array by repeatedly dividing the search intervals in the half, begin an interval covering the whole array. So if the value of the search key is less than the item in the middle, value of the search key is less than the item in the middle of the interval, narrow interval to the lower half. So otherwise narrow it to the upper half. So binary search on a sorted tree that uses the divide and conquer method. Backtracking search on the graph uses the depth first search, DFS. Depth first search. Okay. So the next question, it is suppose if you are provided with the function declaration in the C programming language. So here the programming they are given integer partition function. The function treats the first element, that is A array, as a pivot element and rearranges the array so that all the elements less than or equal to the pivot is in the left part of the array. All the elements that are greater than the pivot is in the right. So for pivot element, the greatest element at the right and smallest element at the left. In addition, it moves the pivot so that pivot is the last element of the left part, and the return value is the number of elements in the left part. The following the partially given function in the C programming language is used to find the kth smallest element in the array A of size using the partition function. So we assume that k is less than or equal to n. So this kth, the smallest element. Okay, so the kth smallest element, the integer array they are given int n int k. So left hand partition, left side they do smaller elements, right side the larger elements. So left hand plus 1 is equal to k, then left hand plus 1 greater than k. So here return the kth smallest, and else the return kth smallest. So here the missing argument are here the return kth smallest, a left end a comma left end comma k, and a plus left end plus 1 comma n minus left end minus 1 k minus left end minus, so the first option will come here. So here a comma left end comma k, and here this part will come. The quick sort is used for sorting the algorithm. Quick sort, we pick the pivot element, then move the pivot element to correct position and partitions the array around it. So idea is not to complete the quick sort but to stop at the point where pivot itself is the kth smallest element, and also not recur for both left and right side of the pivot. Okay. So one more example, consider a typical disk that rotates 15,000 rotations, a disk 15,000 rotations per minute rpm. The transfer rate is 50 and has a transfer rate of 50 into 10 raised to 6 bytes. So if the average seek time of the disk is twice the average rotational delay and the controller transfer time is 10 times the disk transfer time, so the average time in milliseconds to read or write 512 byte sector of the disk. So here there are 15,000 rotations. 15,000 rotation means 60 seconds. 50,000 15,000 rotations per minute. So 15,000 rotations per minute, 60 seconds, and has to transfer at a rate 60,000. So 60 by 15,000 is 4 millisecond. The average rotational delay is 1 by 2 into 4 milli, so 2 milliseconds. The average seek time is 2 into rotational delay, so 2 into 2 milliseconds, that is 4 millisecond, and time to transfer 512 bytes. So here there are transfer rate is 50 into 50 mega 10 raised to 60 bytes. So 512 divided by 50 megabytes. So here we'll get 0.01 millisecond. So controller transfer time 10 into disk transfer time 10 into 0.01. So here we'll get 0.01 millisecond. So the average time is 4 plus 2 plus 0.1 millisecond 0.01. So 6.11 millisecond. Okay, 6.11 millisecond. Assume that the merge sort algorithm worst case takes 30 seconds for an input size of 64, worst case. So following most closely approximates the maximum input size of a problem that can be solved in 6 minutes. So here the answer is 512, means in 6 minutes. For 30 seconds the input size is 64. So most closely approximate maximum input size of a problem that can be solved in 6 minutes. 6 minutes. Okay. So here the complexity of merge sort is O of n log n. So C is constant. So here the for given input n is 64. So C into 64 n log n, O of n log n, that is 30 seconds they are given. So here 64 into 6 equal to 30. So C is equal to 5 by 64. 5 by 64. Now the value of n is C into n log n is equal to 360. So 5 by 64 into n log n is equal to 360. So here n log n is equal to 360 into 60, here 66 minutes, 6 into 60 seconds, so 360. Okay, so here the second 360 seconds, so 360 by into 64 by 5, so here we will get 2 raised to 9, n is equal to 2 raised to 9, so 2 raised to 9 means 512, 512 n value. So here the worst case is 30 seconds for the input 64. So here for 6 minutes how much? So the input is 512. 512. Let G is the connected undirected graph of 100 vertices, 300 edges. The weight of minimum spanning tree is G is 500. Then what is the weight of each edge of the graph? G is increased by the 5. Is increased by the 5. The weight of minimum spanning tree, that is becomes the weight of minimum spanning tree. So here 100 vertices in a spanning tree that contains 100 vertices means that is if n vertices means n minus 1 edges, n minus 1 edges. So for 100 vertices, 99 is the edges given. Spanning tree contains 99 edges given. So weight of the minimum spanning tree G is 500. The weight of the minimum spanning tree is 500 since each edge is increased by the 5. Each edge is increased by the 5. Okay. So the weight of the minimum spanning tree becomes, so here weight is 500. It is increased by the 5. Okay. So into 99 number of edges. So here how much it is? 99 into 5. 90. So 500 plus 495. Right. So we'll get 995. And it is almost here 199 into 100 into 500. 100 into 5 means 500. So 1 5 is not there. So 495. So here 995. The correct answer. So there are 5 bags labeled 1 to 5. The coin in the each bag have same weight. The coin in each bag have the same weight. Some bags have the coins of weight. Some bags have coins of weight 10 gram. Others have coins of 11 gram. One pick 1 2 4 8 6 coins respectively from the bags 1 to 5. The total weights come out is 323 gram. One pick of 1 2 4 8 6 coins. Then the product of the labels of the bags having 11 gram coins is, so that is here the answer is 12.